you should all know this this table because it's from the Book of Odyssey. But just to refresh your mind, what I like about this table is that it shows the different attributes that your research could have, like being repeatable, reproducible, replicable, or generalizable, etc. And in terms of what that means for whether the question is the same, whether it's the same researcher, whether the data is the same, and the analysis is the same, whether you then get the exact same result. And so the topic of today is reproducibility. So meaning if you had the same question, but a different researcher wanted to try to answer this question on the same data using the same analysis, would you get the same result? And so this was basically the process that Anna was describing. And one of the key elements there is this column called analysis. Like, can you actually guarantee that you're doing exactly the same analysis? And as Anna showed you, that if you just have the method section of a paper, then certainly it's extremely hard to get that analysis always to be identical. But it's very important, as you can see here, to get the analysis exactly identical is essential for both being repeatable, reproducible, replicable, generalizable, and even calibrated, which we like to do in Odyssey. So I want to focus here just on how can you make sure that you can keep that analysis the same across all these different scenarios. But before I do that, I want to remind everybody that if your first experience in observational research is Odyssey, then you are probably very spoiled. Outside of Odyssey, and I'm not exaggerating here, pretty much all the research looks like this. And I'm not going to name names, but I've seen this in countless research groups. Typically, you have your database guy, unfortunately, usually a guy, who is the one who actually touches the data in the database on the server. And this person then extracts some data set for the study, hands it over probably as an Excel file to maybe the epidemiologist or the statistician, who then might actually work in Excel, editing some of the files, maybe looking for outliers, whatever. Finally going into SPSS, clicking buttons, and ending up with a result, and that result goes into the paper. Or another way to look at this is that you could say that in most of these groups, the study is seen as a journey from the data to the paper. So the protocol might be the map that sort of tells you the general direction where you want to go, but as you walk the path and you come across obstacles that you may have to overcome, like your date field is in the wrong format, so you may need to change that, or there are some outliers that you need to remove. Some of those steps require manual intervention, and once you actually get to the finish, once you have your paper, then it's pretty much impossible to retrace your steps. And like I said, so most research groups actually work like this, and even if there are research groups that say, well, no, we use SAS and we store our SAS scripts that we use for our study, then more often than not, there are 10 SAS scripts, 5 of which are labeled as final. So really, in hindsight, it's impossible to know exactly what was done. And I'm not exaggerating, I'm just speaking from experience here. So that's not good. So what should an Odyssey study look like? And luckily, most of them actually do. They should look like this. You have the database with the data in the common data model. You have the paper, and then you're building a pipeline that will automatically transform the data from the database into the results. And everybody is working together on building this pipeline. And so actually, when we say performing a study, it's not this walk from the database carrying your data to the paper, it's building the pipeline. And then once the pipeline is done, you have your results, and the paper is also done. But at the same time, you've completely defined the process by which this data is transformed into the results. One important thing I'd like to point out is that you're not allowed to actually peek at the results while you're building the pipeline. So another image that I borrowed from the Book of Odyssey, is where you start with your research question. The idea is then in parallel, you write your protocol and you implement your study, and you look only at the diagnostics, like your covariate balance or your negative control outcomes, for example, in these estimates. And you're basically allowed to iterate over those, building your pipeline as you go along, until you believe, based on your diagnostics, that your pipeline is actually going to produce a valid estimate. Only then do you register your protocol and ideally your study package, although like a site like NCEP doesn't allow you to actually register your code. It just allows you to register your protocol. And then you run the study and get your result. And at that time, you're not allowed to actually modify the pipeline anymore. So like I said, this is currently, luckily, common practice in OHDSI. So each of at least the OHDSI studies that we do as a community comes with both a protocol and a fully executable R package. You can actually find those if you, for example, go to our OHDSI Studies website, or even our OHDSI Studies repo that's behind this website. You can see there all these studies, and all of them have a GitHub repository, as well as usually a protocol when they've finalized that. So what is typically in study package? Of course, code for running the study, but also things like the cohort definitions, because when you're at a new site, you don't want to go through the exercise that Anna had to go through to figure out what the cohorts were. You just want executable cohort definitions, maybe your negative controls, and your analysis specifications. So one fairly recent development is that we started to realize that that code actually, you could have R code, but that actually requires specific R packages to be installed with specific versions. And so currently we're looking at different options of preserving that compute environment with all your packages. So we're currently mostly focused on REnv, which is a solution that's integrated in RStudio and that can run at most institutions and is pretty lightweight. The downside are it's only preserves the R package versions and not R itself. So if you go to a newer version of R, that actually is not something that's easily to restore with REnv. And it's still being developed. So sometimes we're actually surprised at new behavior of REnv. We're also looking at Docker, which has it's in a sense a much more powerful solution because you store the entire environment, including your operating system. But some sites, like the one I work at, doesn't actually allow Docker. So this is sort of a direction of development. Anyway, so that was just a short rant, I would say. In summary, all of our analysis must be 100% repeatable on the same or different data. Each study must be written as a pipeline that automatically transforms the data from the common data model into the study outputs, such as the tables and figures. And the current OHDSI practice is to create study packages, have them in OHDSI studies, and to capture the computer environment in REnv, where some of the people working on this are actually looking at Docker as an alternative or an additional solution, so that if sites can use Docker, they can use that, and if they can't, they can always fall back on REnv. And with that, I'm at the end of my talk. Thanks.